Okay, so the next numerical test for chapter 8 motion, class 9, test 8B. These are the ones, okay, that you write it down. You'll find on pages 109 to 115 of your textbook. So let's go to the first question. The example 8.3 textbook, okay, page 109, you'll find this. Okay, so let us go there. Let me read the question. Usha swims in a 90-meter long pool. She covers 180 meters in 1 minute by swimming from one end to the other end, and back from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. Okay, so here, okay, since Usha, okay, swims, okay, Usha swims, covers, let's just use the same language, covers, since Usha covers 180 meters, okay, in 1 minute, in 1 minute, I think in 1 minute, yes. So that means, therefore, the average speed, we can easily get it from here. Average speed of Usha will be equal to total distance covered by Usha divided by total time taken, right? Because that's the formula for average speed we have learned in our previous classes. So total distance covered according to the question here is 180 meter, and time is here 1 minute. So we write here 1, and so this is meter per minute. So next here, that is equal to we have to change it to the SI unit, and we know that the SI unit of speed is meter per second. So we need to change the minute to second. So how do you do that? 180 meter is fine, so we just keep it as it is. But we're changing this minute to second, 1 minute. So if you want to change minute to second, you're changing big to small. So you have to multiply this 1 by 60. Then only this minute will disappear and the second will come in. Now it is in the SI unit, meter per second. As we said in our previous classes, we're going to primarily use the SI unit, right? So here 6, 0, 0 cancelled. 6 1s are 6 and 6 3s are 18. So this is 3 meter per second. Bring this second to the power plus 1 up, become minus 1 power, right? So this is the average speed of Usha. Now how about the display average velocity? Now we will continue here. Since, okay, you can just continue below this. Since, okay, according to the question, she returns back along the same straight path. So you just write here, since, as we read the question, we can see that she returns back to the starting or initial point from where she started, from initial point. Because this is what the question is saying, the pool is 90 meter long, 90 meter long, and she's swimming from here to here and coming back 180. So coming back to the starting point, see, 90 plus 90, 180 in 1 minute. So she returned back to the initial point. Therefore, her displacement, her total displacement or displacement, we know in our previous classes we have dealt with this. When an object returned back to the initial point, then the displacement is always 0, so 0 meter. So we can write now, therefore, average velocity of Usha, okay, average velocity, her average velocity will be equal to total, the formula we know is total displacement divided by the total time taken, total time, right? So here, total displacement by total time, right? So that will be equal to here. Total displacement is 0 meter. Time is again 1 minute. So you can write here meter per minute. So you can just change here 0 by anything is 0. But you can just deal with this one 1 into, to change it to second, 1 into 60. Then this will become meter per second. We did that just now. So that is 0 divided by anything is 0. So 0 meter per second is our average velocity. Okay, so we have done 8.3. Let us go to 8.4. So example 8.4, textbook, page. Okay, this one we will find it on page 8.4, page number 110. Okay, 110. But we're going to modify this little bit, so you better write the question. The first part of the question, it will have two parts here. A. Let's deal with that first. Part A of the question. We are modifying this question to suit our purpose of numerical, okay? So let us say, I'll use a different name, Libemo. Okay, Libemo paddles his bicycle. Pedals his bicycle from a stationary position, from a stationary position, okay, from a stationary position to attain a velocity of 6 meters per second, to attain a velocity of 6 meters per second. So it's already in the SI unit, okay, in 30 seconds, in taking a time of 30 seconds. Okay, so find his acceleration. Let's write this one. Find his acceleration. Find the acceleration or his acceleration. Okay, so for these numericals in this chapter, you have to keep these formulas here, especially 2, 3, and 4. The three famous equations of motion. You have to memorize it thoroughly. V is equal to U plus AT, right? S is equal to UT plus half AT square. Twice AS is equal to V square minus U square. Get it thoroughly memorized. And the formula for speed, though, you already know, distance by time. And it will make it easy for you. Okay, so here, let us solve this one. So solution or your answer. Here, sorry, Libemo pedals his bicycle from stationary. So underline the word stationary on your question. Stationary means that is the initial velocity. The starting velocity is called the initial. Started from. Stationary means that is U. Stationary means not moving, so the velocity will be 0 meter per second. This is called initial velocity, his initial velocity. And attain a high velocity of 6 meter per second. So first one appearing is called initial velocity U, and the next one appearing, the final one, is called V. This is called final velocity, is 6 meter per second. So this is your final, his final velocity attained by his effort on the pedaling, by the effort put by him to pedal. Find his acceleration. So we have to find A, question mark, that is his acceleration produced. Now listen carefully. Now, which of, once you write down the values, out of the three famous equations, usually most of the sums will be coming out from there. So which of these three will be using? Find out yourself. So here you have U and V is known. So U and V known. T is also known. So here time is there, see. In 30 seconds means, even if they didn't tell us it's time, the unit second is telling us it's time. So you write here T. We'll use T, okay? 30 seconds is the time taken by him. For him to move from stationary position to this final velocity, he took 30 seconds. So that is the time. So here we know V, U, and T. So easily we can use equation number 2 to find A, right? The one the question is asking. So let us use the famous equation. First one, V is equal to U plus AT. Then let us change this one here. Here, see, I'll just write AT is equal to V, and then you shift this U. No sign in front of U means plus, so if you shift, it will go to the left side, means minus U. So now don't move this A. Okay, and then if you don't move, then this also don't move, V minus U. Then if you shift this T, it will go down below that. I'm just bringing this A this side, okay? So now we can use this formula to find your A. So let us do that. So that will be equal to, V is here 6 minus, U is here 0. I didn't write the unit because both of them have the same unit, meter per second. So you can take it out of common, out of the bracket, meter per second. By T here, 30 seconds, so you can just write there 30 seconds. Now here, we'll do this one slowly and detail, okay? Then from the next, you can just start doing directly in sum, okay? 6 minus 0 is 6, right? Divided by 30, and then meter per second, this one same. And here, no power means we know, we don't write, so the power is plus 1. If you shift this second to the power plus 1 to the numerator, it will become another second to the power minus 1. So this is 6 5s are 30. So this will be, or we can just make it like this, so make it easy. 2 1s are 2. Okay, 3 is going 3, 1s are 3, 3 zeros are 0, 3 2. That way, easy to divide. So 2 divided by 10 is, decimal is here, move left to the left side of 2, then it becomes 0.2. Then meter, and here power is minus 1, and minus 1 means we know that when they are multiplied, the rule is you add the exponent. So minus 1 is minus 2. So we learned today unit for acceleration is meter per second square. Okay, so you write here meter per second square. So SI unit of acceleration is meter per second square. SI unit of speed and velocity, both initial and final, is meter per second, but acceleration is meter per second square. Okay, so because acceleration is the change in velocity, right? Is the change in velocity. Okay, so here is the rate, is the rate of change of velocity. So divided by time, therefore second square. Okay, so this is the answer for his acceleration. So we can write here which is positive because it is plus value. Therefore, his acceleration is 0.2 meter per second square, comma, in the direction of motion. When acceleration is positive, acceleration is happening in the same direction with the motion of his bicycle. Okay, that means, in other words, the speed of the bicycle is increasing. Okay, so that is called positive acceleration or acceleration in the direction of motion. Okay, so this is your answer. Then B, under the same question, sub numerical B. So you write the subheading B. So there, Rahul, from a velocity of, this is the reverse of what we did just now. Rahul from a velocity of 6 meter per second, okay, 6 meter per second, from a velocity of 6 meter per second on his bicycle, suddenly applies brakes. So suddenly applies brakes, and the bicycle slows down. Bicycle slows down. You have to write this question, okay, yourself. We're adjusting it to make it a numerical, okay? So slow down to 4 meter per second. Slow down to 4 meter per second. In the next 5 seconds, this happens in the next 5 seconds. Means after he apply brake, it slows down to 4, go down from 6 to 4 in a time period of 5 seconds. Okay, so here his initial velocity here, solution, starting when he started, when the question started, he was at a velocity of 6 meters per second. So that this is initial velocity. And finally, after applying brake, he went down to 4, so that is called final velocity. And then acceleration is what we have to find. So find his acceleration is the question. Find his acceleration. So acceleration is a question mark. His acceleration is what we're going to find out. Now this all happens in the time period of this time, 5 seconds. Now this is the reverse process of the one we've done just now. In the previous one, Lebesgue was starting from 0 meter per second stationary to high speed. So his speed is increasing. That's why it's positive. But this time, Rahul was already at a high speed and he's applying brake to stop the bicycle, the reverse of the previous numerical. This will help us to understand the two types of acceleration. So let us do that. So we know we will use the same formula because u, v, t is there. So up to here you write same. Okay, so write same and compare with the previous one. You'll learn something here. Difference between positive and negative acceleration. The first one was positive. Now, so here A equal to V minus U by T. So V is here 4. So we write 4 first now, minus. U is here 6. So we write 6 here. And common, both of them same unit. Meter per second, you see? Meter per second, meter per second. So common factor so that unit can be brought out of the bracket. The time was 5. So you write here 5 seconds. Now we all know that 4 minus 6 is minus 2. Here, minus 6 plus 4. Subtract, we'll put the sign of the bigger number now, minus. So minus 2 by 5 meter per second into this one brought up again. I've already explained, so second to the power minus 1. So this one will be on dividing this. You're going to get here 2 divided by 5. So 0 point only, then 1 digit because it's lesser than 5. 5 4s are 20. So this will be minus 0.4 meter per second square. Minus 1, minus 1, minus 2. The unit of acceleration, meter per second square. Which is now this time, see the difference? The value is now negative. Okay. So because it's negative, his acceleration, Rahul's acceleration is minus 0.4 meter per second square in the direction opposite. You can write here. Now it is in the opposite to the direction of motion of his bicycle. That means his bicycle is moving from left to right, then acceleration is happening from right to left. That's why it's called, it's slowing down. See, minus 4 meter per second square means he's applying the brake. So whenever acceleration is negative, it is a picture of an object slowing down. Whenever acceleration is positive, it is a picture of an object slowly increasing its speed continuously. Okay, so this type of acceleration is called negative acceleration, or some textbook even call it as deceleration or retardation. Negative acceleration. The first one, Lebesgue, was positive acceleration. Okay, so this is the numerical 8.4. One more is there before we complete this part, so let us go to that one. Example 8.5, textbook page, let's go to 8.5, example 8.5. Okay, so the last question before we go to the next one. So 8.5, textbook page 115, I think. Yes, so let me look at the question and read the question for us. We'll do slowly. Textbook 115. Open your textbook to that. So here now, let me read the question. A train starting from rest, very important, attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, means acceleration is happening at a uniform rate. Find the acceleration A and the distance traveled, that means S. Here the word S denotes distance. Let me say once. Final velocity, initial velocity. A is acceleration, T is time, S is distance. Already explained this part. So here, A acceleration, distance. So please keep that in mind. Okay, so here, since the train, clearly the train starts, look into your question, starts from rest. Okay, from rest. Train starting from rest. Okay, starting from rest attains, according to the language of the text, attains a velocity of, look into your question, 72 km per hour. 72 km per hour, like this the textbook is using. So in 5 minutes, so what does this information give us? That means here, underline the word rest, means initially it was at no moving, so U, initial velocity will be 0 meter per second. We are going to use SI unit, okay? And then after some time it attained 72, so that is final velocity 72 km per hour. But we have decided to use meter per second. So we need to keep these two thoroughly memorized in our mind, because you're going to need it frequently in this physics, not only this chapter, but almost all the chapter, and even in maths also. So better memorize than these two here. Conversion for distance or length, this one for time. So here, let us do that. So you're going to change kilometer to meter. So let us count. 1, 2, 3. You're changing big to small, so multiply by 3 zeros. Because 1 is, here factor is 10. 1 kilometer, 10 hectometer. 1 hectometer, 10 decameter. So 10, 10, 10 means 000. Then the kilometer will disappear, meter will come in. Then hour is going to be changed to second, because SI unit of time is second. So now, here, SI unit follows the MKS system. We already discussed this in the first class. So here, MKS system, SI unit follows this, means for length we'll use meter, for mass we'll use kg, and for time we'll use second. That's the meaning of SI unit. SI unit of distance or length is meter, mass is kg, and then time is seconds. Okay, so here, so second, hour to second means we are moving 1, 2 place to the right, big to small again. So this no number down in the denominator means 1, so divided by 1 is there, into 60 into 60, because there are two movement, 1 and 2. So then meter will, hour will disappear, and then in place of hour per hour it will become per second, which means we can simply write second to the power minus 1. So we can cancel this 0 and 0, and 2 3s are 6, and then 2 3s are 6, 1 and then 2 6 are 12, 0. Then here 3 1s are 3, 1 3 2s are 6, 3 0. So again here 6 can go, 6 2s are 12, 0. So this is finally coming out 20 meter per second. Right, so time finally, here time, 5 minutes here, means time is equal to 5 minutes. So this is the initial velocity, and this is the final velocity. So we have to change this minute also to second. So 5 minute to second means only one place, so 5 into 60 seconds, so that is 300 seconds. Now everything is in the SI unit, so we can find out what the question is asking us. Now let us go and see here. The question is asking us here, A, go back to question. I think subheading 1 they are using, sorry. So here, 1. Okay, look there into your question. Find the acceleration. So that means A, question mark, the acceleration you have to find out. 2, what do you have to find out? The distance traveled by the train for attaining this velocity. So the distance is s, question mark, the distance traveled by the train before it attains this high velocity. So it is a picture of a train starting stationary and increasing the speed to reach 72 km per hour. So to attain this high speed, it took 5 minutes. So, okay, but how much distance was it covered before it attained? That's what the question is asking. So let us do with 1 first. Now here, A you have to find out by using these values. U, V, and T is there. So find an equation which has A. U, V, T is there, A. So we can use the first one. Since V equal to U plus AT. Okay? And this time, I'll just do it directly because you know now we're going to find A means this one, don't move this side, minus U. And this T into means come down to the denominator directly. The previous sum I have shown you detail. Now we understood, so we'll do directly. Okay, so V, here, go there and find out V. We have to use the SI unit, so 20 minus U is 0. So you just write there is 0. Common unit is meter per second. So you write that down by time is here in seconds we have to use. Remember SI unit, not the minute. Okay, so here 300 seconds. So now 20 minus 0 is 20 by 300. Then meter per second into this one go up. We know now second to the power minus 1. So here you can cancel this 0 and 0. 2 1 and 2 ones are 2, 15. So 1 by 15 meter per second minus 1 minus 1 minus 2. So power is minus 2, which means meter per second square SI unit of acceleration, which is positive. So acceleration is happening in a direction of motion. That's why the speed of the train is increasing. Negative means it's slowing down, right? So at this rate of acceleration is going. That's your first answer. Okay, now 2. Second part of the answer, you can continue. Number 2, to find this distance. Since we know this formula, S is equal to UT plus half AT square. We'll just put like that because we know we can find it out directly. See, S equal to this one. This also you can use. V, U is there, A is there. Even if you use the fourth formula, also you'll get same answer. But I'm using this because it's already arranged for us, so it'll be easier maybe. So they'll be here. U is, we know, 0 meter per second, right? So meter per second, if you want, meter per second, okay. Into time is here 300 seconds. Plus half into A, just now you got here, 1 by 15 meter per second square. Okay, then here into T square. So T is here 300. So let us put there 300 into 300. Please remember T square, so second into second square will come here because this is not T, this is T square. So now we can just, before that, meter per second square like this is the same as, you know, you bring this minus 2 power down, then it become S square, right? So this way we can cancel this S square and S square because everything is multiplication sign there. Then here 15 2s are 30, 0. 2 10s are 20. You can just keep it cancel. This one is very easy. 0 multiplied to anything is 0. So this portion you need not even bother anymore, disappeared. So this part is your answer. So listen carefully. 300 into 10 is 3000. And then here meter is left. Okay, that's your answer. Or suppose the textbook asks you to find in kilometer, then you divide by, here see, starting from here, you don't count the first one, 1 2 3, then sorry, meter to kilometer, so you have to move left, 1 2 3, small to big. So this time divide by 3 zeros. So that means 1 2 3, see, 1 2 3. Then meter will disappear, kilometer will come in. So your answer is 3 kilometer if they asked in kilometer. Otherwise, this answer will be fine. So first is acceleration, 1 by 15 meter per second square. Second one is 3000 meter. Okay, this concludes the portion. Okay.